So in learning objective A, we're going to calculate probabilities using conditional probability. I'm going to show you how you can do this through a thought process and also through a specific formula. We're going to be back to the Titanic data. Here's the question. Can you determine the probability, just means a fraction, that a randomly selected passenger survived given that the passenger was in second class? Now, Section 6 and Section 5 are very similar. Section 6 is very intentional, though. It's called conditional probability. And in conditional probability, they're going to list a given statement. So it's going to come second, the group that we're looking at. So really, given the fact that the passenger was in second class, that is who we're looking at. So the group are these people. And remember, if we total it, 285 people. So let me reread it for you. What's the probability that a randomly selected passenger survived, given the fact that they were in second class? So we're just looking at the second class people, just as survivors. So the answer here is going to be 118 over 285. Now, here's the math shorthand for that. So here's the math shorthand. You might see this. Find the probability that a passenger survived. Just going to abbreviate. Then they're going to put a straight line. That's the word given. And they're going to say that the passenger was in second class. So conditional probability is written with a straight line. Again, that symbol means the word given. Now, sometimes you can just look at the table and compute the conditional probability like we just did. But sometimes they might give you a formula. Let me show you this formula. Now, if we read it like we just learned about this notation, this would say, find the probability of event B given that A happened. So what you're going to do is you need to look at all of event A, and within there, B is going to be embedded in there. Now, the formula would be this. On the bottom of the fraction, you're going to find the probability of event A happening. On the top, it's the probability of A and B happening. Here's what I imagine. If you take this looking like a fraction and you just rotate it 90 degrees, as a fraction, that the A kind of ends up going down to the bottom. So that's how I remember it's the probability of A on the bottom. So let's redo that same question that we just did, but using the formula. So again, here was the question. Okay, so we had written it, the math notation, the probability the passenger survived given they were in second class. So based on this formula, the bottom of the fraction is going to be the probability of this. So it would be to find the probability the passenger was in second class. Now on the top of the fraction, we're going to put both events. The probability, I'm going to put that the passenger survived, and at the same time, they were in second class. So let's do the bottom fraction first. The probability that the passenger was in second class. Now we're looking at all the passengers in this complete statement. So that would look like, if you're in second class, there's 285. 285 out of 2,201. Now here, what's the probability of everyone that the passenger survived and was in second class? So they survived and were in second class is 118 out of 2,201. If you simplify this, you technically would multiply by the reciprocal down here. And then on the top, you'd multiply by the reciprocal. And what you're going to get is 118 over 285, which is what we got when we first did the problem, just thinking through it. So for me, I think doing it the first way was easier versus using this formula. But sometimes you will be given this formula notation, and they might just tell you the probability of A and the probability of A and B, and you would just plug it into the formula. Okay, let's do this example here, actually using the formula. So the first question here, here's a scenario. B is the event a person eats a good breakfast. L is a person eats a good lunch. Suppose in a group of 80 people, 43 eat good breakfasts and good lunches. 21 eat good breakfasts, but not a good lunch. 12 eat a good lunch, but not a good breakfast. And the rest eat neither. This is pretty confusing data, so what I'm going to actually do is make a tree diagram to help me see it better. So I'm a person, and I come in here, so there I am. Now my first choice for the day is I'm going to eat breakfast. Breakfast is either going to be a good breakfast or it's going to be a bad breakfast. Okay. So now after I made that choice, lunch comes up. Let's say I had a good breakfast. Well, now I have another choice. I can either have a good lunch or I could choose a bad lunch. Now if I had chosen a bad breakfast to start with, I could redeem myself and I could now have a good lunch, or I could continue and just have a bad breakfast. So here we can see there's 4 different possible outcomes. For example, if I'm the person, maybe I had a bad breakfast, but I could have a good lunch. So these 4 different branches show me the possible outcomes. Let me put some counts to what they're telling me here. So suppose a person in a group of 80, so we know the total at the end here has to be 80 people in total. So here it says 43 eat good breakfasts and lunches. So good breakfast and good lunch would actually end right here. So this is 43 people that do that entire branch. 21 eat a good breakfast, but not a good lunch. So good breakfast, but not a good lunch is 21. 12 eat a good lunch, but not a good breakfast. So a good lunch, but not a good breakfast is this guy right here. And the rest eat neither. So if you look at it, 43, 21, and 12, if you have to subtract that from 80, you're going to get that the difference is going to be 4 people. Great. Now we have the tree. Let's answer the questions. So question A, find the probability you have a good breakfast and a good lunch. So this is just regular. A good breakfast and a good lunch would be a good breakfast, a good lunch. That's easy enough. It's going to be 43 out of 80. Now, part B, let's do the conditional probability formula. It says here, what's the probability I have a good lunch given I had a good breakfast? So what I would do on the bottom is put the probability of B and the probability of L and B on the top. So the probability of B, which is right here, is the probability of having a good breakfast. Probability of having a good breakfast would be right in here, everyone on this branch. So if you total all of this up, there's 64 people out of the 80 are going to have a good breakfast. Now in the top half here, the probability that you had a good lunch and breakfast. Well, a good lunch and a good breakfast is right here. That's going to be 43 out of 80. When you end up simplifying it, you're just going to get 43 out of 64 is the answer. Okay. Now maybe you didn't need to do the tree, so let me show you if you didn't use the tree. What's the probability you had a good lunch given you had a good breakfast? So given the fact you had a good breakfast, if you look at it, I'm just looking at these folks. So given you had a good breakfast means I'm just looking at the 64 people. So what you're doing is of those 64 people who had a good lunch, you had 43. So I personally just like to look at the data and come up with that they're saying the probability you had a good lunch given you had a good breakfast. My good breakfast people were 64. Of those, 43 had a good lunch. Okay, let's do part C. The probability I had a good breakfast given I had a good lunch, so they're just going to reverse it. So the formula would look like this. So let's go ahead and find the probability you had a good lunch. Well, the good lunch people, we have, here's 12 and here's 43, so that's going to add to 55. So that's 55 out of 80. Now the probability I had a good breakfast and lunch, that's still going to be the 43 out of 80. So then this is going to simplify to 43 out of 55. Okay, again, let me show you if I didn't use the formula. Find the probability I had a good breakfast, given I had a good lunch. So I'm going to look at given I had a good lunch. If I had a good lunch, all I'm looking at is this and this. So that is the new total of my fraction. It's of the 55 people. Of these people, of 55 that had a good lunch, how many had a good breakfast? 43. And I could come up with a fraction that way.